Hello everyone. Am I audible? Hello.
You are audible, ma'am.
Screen is visible.
Yeah, it's visible.
Good evening everyone. Welcome to week 1 problem solving or tutorial section course system design through Verilog. So uh, let us have like it to be a very interactive section, so you can turn on your mics and speak. Week 1 introduction to Verilog. So first let us start with the basic VLSI design flow. So first we will like first step is like specifying the design. So like you will specify the input and what is the operation you want the system to perform, and how many bits and what are the outputs you is required. Then you start with the behavioral level design, which is a high level design. Then you synthesize this high level design using some EDA, so you will obtain a gate level netlist. And then this gate level netlist, you will use it to generate the test patterns, and you will perform the verification. Followed by you will perform the physical design, which includes the placement and routing PNR. And then followed by physical verification, then fabrication, packaging and testing, and you obtain the final chip. So Verilog is a hardware descriptive language, HDL language. So any like if you have say you want to test one AND gate, a simple circuit, say this you wish to test it, then you can connect this in a breadboard and test it. But when you have millions of gate, we go for the coding languages like Verilog. Verilog is syntax are similar to C language. The number representation in Verilog you will represent with first size, the tick, then the radix and value. So like if you want to represent any 2-bit octal value, say the value is 1, 2, then this is for radix. You will have O for octal, H for hexadecimal, and D for decimal, and B for binary. And then these are some of the arithmetic operators like asterisk for multiplier, division, addition, subtraction, and modulus is like if we say 10 mod 3, the output will be 1. Then we have logical operators as well as bitwise operators. So logical operator, for example, if I perform take 0 101, which is decimal 5, and perform a logical AND with again 5, what will be the result?
One.
Yes, please. If I perform a logical AND,
It will give one.
yes, and if I have, we have another type of operator called bitwise operator. If I perform bitwise AND,
And it is 101.
yes, and then we have like relational operators less than, say like if I say 0 less than 1, the value will be true, which is nothing but binary 1, and greater than, this is for less than equal to, greater than equal to. Then we have equality operators, uh, like these two are for case equality, means this includes x and z value. Here the z indicates high impedance state. say like I have a gate, I am driving this circuit and I have left this wire open. This state is indicated by Z, high impedance state, and this high impedance state and X is not included in this double equal to and not equal to. Then these are the like shifting operator, right shift, left shift, and then conditional operator where you write the conditional expression semicolon then followed by true and false expression. So like we can implement 2 cross 1 mux using this conditional statement. So like consider a 2 cross 1 mux, this be select line 0 1, this be A, let this be B, and this one out. So like now can you say how can I write implement this multiplexer using this conditional operator? Like I will have out equal to the expression
L
and then true value.
B B column E.
Yes. Then we have the data types, wire type and register type. Wire type is used to like continuously driving values. Like I have an AND gate, I am driving this say, on another OR gate. I am driving this net continuously. So I will define this intermediate value as wire. And register type if you want to store any value. And the default value of this net, if I like don't connect here, then the default value will be Z. And the default value of a register type is don't care. So if I want to like specify scalar means 1 bit, I will have wire 1 or register type means reg r1. And vector, I will represent like wire MSB to LSB then X. So if like I want to say 4-bit X register, if I want to specify, then I will be specifying it as reg 3 down to 0 X. Now if the same thing, if I have wish to specify say uh, 4 array of 4-bit register X, then what will be the like assignment, the declaration? Reg 3 down to 0 X followed by I wish to specify 4 array of 4. So I will specify the array value here. It will be 0 down to 3. Then the syntax of the module, it will start with module and end with end module. Then module name, you will define all the port list, all the input, output and in outputs. So then with like here itself you can define like input A comma B comma output out, or you can define here A B out and then separately define which are like input and which are output port and which are in output. Then followed by you will have the continuous assignments any module if you want to instantiate, and then procedural assignment and the end module. This is the like basic syntax of the module in the Verilog. So like we have here both continuous assignment as well as the procedural assignment. We will discuss this. So like procedural assignment where you are assigning this will be a net type variable. Okay. And then what any variable, any operation you want to perform and then assigning it to the output variable. So example assign out in and into. And then procedural assignment, you have two types. One is blocking assignment and the other one is non-blocking assignment. The assignment operator is equal to and less than equal to for non-blocking. So okay, let this be the first code and this be the second code. Here I have used equal to and here I have used less than equal to. So which one will be the blocking and which one will be the non-blocking one? The code for one will be the blocking or non-blocking. Hello, I'm audible, right?
The first one is blocking, and the second one is non-blocking.
Okay. So in the blocking statements, it will start the execution and follow the order listed here. So it will execute this. After completing this, it will execute this. So if I like as have the A has 0 and B has 1, then this Y1 will be equated to 1, sorry, 0, and then this expression will be evaluated like 1 and 0. So Y will be 0. But whereas in the non-blocking, the value of A will be stored in some temporary register, and this expression output, which is nothing but, now we don't know A because it y1 is still not assigned, it is in some temporary variable, so it is don't care, and then B is 1. So here you will obtain the y has x, it will be also in some temporary variable. After completion of this block execution, the values from the temporary register will be stored back to y. So we will obtain y has don't care. And now, like in the Verilog, we have three types of modeling, like Verilog modeling, gate level modeling, data flow, and behavioral modeling. In gate level modeling, you will define the all the instantiation will be gates. These are like primitive gates, predefined gates in the Verilog. We have and, or, not, and then the rest of the syntax is same, module and input output and then end module. In the data flow, you will be using these operators. In the behavior, like it is a very high level coding, so you will be directly like implementing the truth table. So if I have and get 0001, so it is 0 when any one input is 0. So we will directly write the if statement. If A is 0 or B is 0, then the output will be 0, else the output will be 1. The same way implementation of a 2:1 multiplexer. So this is using the gates and using the operator, or else you can directly implement using the conditional operator. And in the behavioral level, we are implementing the truth table. If the selection is 0, we are selecting the I0, otherwise I1. So designing of the combinational circuit using the gate level modeling, we will first define the input output, the number of input outputs, truth table, then the Boolean expression and simplification using K-map, then logic diagram followed by Verilog code. So example, let us take a 2-bit cube. So the maximum we can represent 1 1 in a 2-bit number system, which is nothing but 3. 3 cube is 27, which can be represented as 8 4 2 1 16. So we'll get, okay. So we need 5 bits to represent the 27, and input is given 2-bit. So we write the truth table, and this is the decimal equivalent for 2 square 0 square 0 cube 0, 1 cube 1, 2 cube 8, 3 cube 27, and the equivalent binary representation. Followed by we will write the expression, like here it is 1, so it is 1 1, a0 and a1. For y3, this 2. So it's simple, so like we can directly use the Boolean algebra to solve this. So a0 a1 bar or a0 a1, we will obtain a0. Y2 is 0. Y1 is again a0 and a1, a0 and a1. So this you can draw the combination logic diagram, like you can have a0 a1 and a0 a1 and is y4, it is y2 and y1, and your y3 is a0 and y2 is ground. And then the so this we can implement y3 y4 is a0 and a1, which is this is a0, y2 is 0 and y1 y0. So here first to write the Verilog code, this is the expression. So the inputs are a0 a1, two inputs, 5 outputs. This is the port list, and this is the user defined name for the module. Start with module and end with module. And in this a0 a1 are input and y4 to y0 are output. And then this is like I'm instantiating a primitive gate AND gate, and the instantiation name gate 1. This is also user defined name. And then for here output followed by input. So y4 is the output, a0 a1 is the input, and for g2 I want a1 a0, so I can have a0 and a0, which is equal to a0, and y2 is 0, so a0 and 0 will be 0, followed by g4, which is a0 and a1, a0 and a1. So with this, the basics of Verilog and the example of module and one combination circuit we have seen. Any doubts till now? Any doubts, or you wish to discuss some other questions? Yes, any doubts? If no doubts, then we will proceed with the some of the previous year assignment questions.
Madam,
Yes,
how can I get this PDF, madam? Material, this one. Yours.
we will upload in the sheet. I think that will be shared with you. This will be uploaded in the YouTube, this video, and the sheet will be like this PDF will be saved in a drive and then shared with you.
Okay, madam. Thank you.
Yes. Any other doubts? So we will start with the previous year assignment questions. So which of the statement is false? Can anyone answer? So this is like logical AND operator, and yes. So we have like 1 and x can be 0 or x can be 1. So here we will get 0, here we will get 1. So this we are representing as don't care. And then this one synthesis tool produces. So input we will be giving the behavioral level, high level coding, and then the output of the synthesis will be
Netlist.
gate level netlist. And then like okay, this is the given is 2 tick O 1 2. This represents, so here we have 3
A,
figures.
ma'am.
Yes,
A. Option A.
option A. Why not B and C?
Ma'am,
All the above, ma'am.
octal, it is grouping of three, ma'am. So one can be represented as one and two can be represented as 0, 1, 0.
Okay, and not B, like this is A.
A is 10, ma'am. Option B. We cannot choose that.
Option B, it is representation in H, which is hexadecimal format. So the number will be from 0 to 9,
10, ma'am.
10, and A to F. So to represent, like, this is the size. So we have 2-bit and the separator tick, and then O for octal, and this is the value. And 12 in octal, each number we can represent with 3-bit. So for 1, and for 2, 0, 1, 0. So with this we can represent as 4 tick B 1010 binary. The equivalent of decimal of 1010 is
10, ma'am.
and the decimal 10 is also a 2-bit. So this can be represented
Yeah,
as
ma'am.
A. Okay. Why not B?
11, ma'am.
11. No, it will be octal 2 will be,
All of the above would be correct, I guess, ma'am.
so this in the octal it is 12. When we convert it to binary, we will have 001 010. So we can represent it with 4-bit, 4 tick B 1010. So A is correct option. And if we convert this binary to decimal, we will obtain 10, because it's 8 4 2 1, 8 plus 2 10. So option C is correct. To represent 10 in hexadecimal format, we have from 0 to 9 and 8 to F. So to represent 10, we will be having letter A and H for hexa. 1 bit represent this 10. So B is also correct option. So all of the above. Then which of the following Verilog inequality operation is false? So here we have both Z and X. X indicates don't care and Z indicates high impedance state. So we have triple equal. So this is case validity.
Option A, ma'am.
Option A. We have ZOX1. It is equal to ZO1. So here we have don't care, but here we have 0. So this cannot be equal. Whereas here x0, x1 and given is itself not equal to, and we have first is x, then 0, 0.
Option B, ma'am.
No, we are asking which of the statement is false. So x0, x1 is not equal to x0, 0, 1. This bit and this bit are different. So the answer is true. So this statement will be correct. Is it fine? Because it is given not equal to equal to. Not is this operator is for inequality. Is this okay? So option A is wrong. Option B is correct. Option C is Z0x1 not equal to Z001. So this bit and this bit are again different. So this is true. So option C is also correct. Option D is Z0x1 is equal to Z001. This bit and this bit is different. So this will not be equal. So option D is also correct. So the false statement is option A.
Ma'am,
Yes.
if option A has only two equal to's, then what is the output, madam? Is it 1 or 0?
Okay. We can try this in the practical section. We will try both with the 2 equal to and 1 equal to and means 3 equal to using a EDA playground, which is an open source Verilog simulator tool. Okay, we
Okay,
can
madam.
discuss it there. So next question, if A is 4 tick B 1010 and we are performing a shifting operation, then the value of D is, this is like which type of shifting operator? Left shift or right shift?
Left shift, ma'am.
So if we have 1010, we will shift by left one step and we will consider the 4 bits. So the answer will be D. Same if we have like right shift by 1, then the answer will be
0001.
this one. I will be 1010. I will shift by right. So it should be 10101, right? I have to shift the right side by 1. And this bit I will be
Okay, okay.
if I shift this by right, then
Four zeros, ma'am.
how because I will have 30. This one I will shift by right. I will then next. Which of the following Verilog data type statement is true? So what will be the default value of net type and the register type? What will be the default value of a net type variable? And yes, please.
Option A, ma'am.
Okay. So this variable I will define it with net type. So the keyword wire will define it as a net type variable, and the default value will be z. Register is for like storing, and we will register the keyword, and default value is don't care. And the z indicates high impedance state, and x denotes don't care. So the value can be either 0 or 1. So next, like we will try some examples directly in the EDA playground. So this is an open source tool. I think you will be familiar with. This is for simulating the Verilog codes or any other HDL codes. Are you able to see my screen? The EDA playground website. Yes. So are you able to see the EDA?
Yes, ma'am, we can see.
Yes, ma'am.
Yeah.
Yes.
So we can like try some. So first, to define any module, we will start with module and then end with end module. So module and then followed by port list. So A, B, and say out. And then input A, B, then output. So I will have always block. So I wish to execute it whenever A or B changes the value, and then begin and end. So here I am checking like if A equal to B, then I am assigning out equal to 1, else I am assigning out is equal to 0. Okay. So for this is a procedural block with always, which will execute whenever A and B changes. This is the sensitivity list. So out should be a register type variable. So if I click unexpected token, line number 2. Okay, I forgot to write the module name. So, well, okay. Then to apply the test stimulus to this equal to module, we need one test bench. So I'm just defining it. In the later sections, we will be covering the test bench also. So the input value I have to store it in order to apply it. So it should be a register type value. Now screen is visible. Always at the rate of a comma b. So here this is known as sensitivity list. Whenever A changes or B changes, this block will be executed. So the syntax is always at the rate of sensitivity list begin and end. So in Verilog you will be knowing like this we will represent with the keyword begin and end. And here you will have some statements. So this is a procedural block. So here this RHS should be a register type variable. And for example, if we have a clock which is having a positive edge and a negative edge, so this is like pos edge and this is like negative edge. So in the sequential circuits, if I am defining this as clock, then if I want to execute these statements only at the positive edge of the clock, I will write like always at pos edge CLK. If I wish to execute at the negative edge alone, so I will define as neg edge clock. Is it clear? Now the screen is still blur, or is it fine? I hope now the screen is fine. So here, like the input variables are A and B. So we have to store the values in order to pass this input stimuli to the module equal. So I'm declaring it as register, and output I'm defining it as a wire. Now I will instantiate this equal block. So equal and name, and then I will pass the input V out. As I am like using the same order, so I'm directly passing it through the variables. Otherwise we will be using like a dot a, which is same as in this module name, in the bracket the variable used in the test bench, comma dot b with the name used in the module and the name used in the test bench. So this is another syntax for this module instantiation. And then now we will have initial, begin, and then end. Yes. Am I audible now? Now is it fine? Now you are able to hear me, or
Now it's fine.
so here I will apply the value for A, which is okay 0, and B is equal to, I have used triple equal to, so it should include X, and is the Z value, so I'm defining it as X. So I have to define like one tick B X and one tick by B for binary. Is this fine? Like I have applied some input initial values to the block equal. Okay, now we have to print this value. So I will use always again, and if I put asterisk means this block will be always executed. So this is only test one, so I am using always asterisk, and dollar monitor is one keyword used to display the uh, values. So its syntax is similar to like printf statement. Dollar time to obtain the time if I'm using delays and all. So, and I have to print a equal to percentage b, b is equal to percentage b, and then out equal to percentage b, a b module. Still I am not audible. Is it fine? Because I have received one message. No, ma'am. Am I audible?
Fine, madam.
So like I am using triple equal to, so it is a case inequality state, case equality. So it should be considering x and z. If I keep a triple equal to b, so it is not equal. So the output should be sorry, I didn't get your question. Simulation is possible with EDA playground means? Yes, simulation is possible. Can you please elaborate the question? Hello? Now is it audible? Is it fine now? Audible? Okay. So, is simulation is possible with EDA playground means like this Verilog simulation you are asking? Or you can please turn on your mic and then you can explain maybe.
Yes, ma'am. Can't we see the waveforms of those A, B? Like,
Yes, for that you have to use dollar dump. One keyword is there. If you want to see the waveforms, you have to dump this waveform files, and here we have an option. Let's see, EP wave after run. This you have to enable, and then so the keyword is like dollar dump file, and then dump dot acd, and then so now you can see it is loading the waveform. So the value of x is 0, b is don't care, and the output is 0.
ma'am, can you explain those lines?
Yes, it is like I am using this dumping this waveforms, and then so these are like system keywords to store the all the as a waveform and then display it as a waveform.
Dump.bcd the for everything that is.
.vcd is the extension, and
So whatever the file, we can write those two lines and we can simulate.
yes, and this dump is your keyword. It is your own wish. Like you can give anything, but .vcd is the extension.
Okay.
And then coming to your question, if I have 0 x and only 2 equal, so it will not be considering 0 and x. A 0 and x, it is not considering this don't care, and it is giving output as 0. So maybe we can like try with more number of bits. Okay. Another way of defining the input is here itself in the port list. You can define input, and I will define a 3 variables, so 0 down to 2, and this is the output, right? So other places, here there will be 2 down to 0, and then 2 down to 0. So it is 3 bit. This should be 3 bit. So can you try what will be the output? You can see the inputs are 101 and 1x1. Yes, can you try? And the operation is A equal to B. Okay. So input is 5. It's 101, and the B value is 1x1. So it is having don't care, so the output it has given us all zeros. So whenever you want have some don't care or z value, you have to use triple equal to, and here you can see this is the output printer from this line of the code. $monitor 0 for the 0 time scale, and then value of A, B, and then output variable.
these two are not equal, so we obtain 0, 0, 0. So like my variable is 3, but I have defined 4 values, so it has taken the last 3 values and the output is not equal, so it's 0. So I can the slash asterisk is used for block commands. If I want to comment a block of a code, and yes, 101 and 1x1, if I compare as not equal to, it is giving me all zeros. Again, if I compare with double equal to, also it is giving me all zeros. So if your like expression has either x or z, you should be using the case equality only, otherwise you will obtain all, like the output will has 0 only. Is your doubt cleared? No, Cadence tool is licensed tool only. Open source tool is not available for Cadence.
Yeah, ma'am, here we are using some fixed values, right, for A and B.
Yes.
Yeah, instead of that, we can try to simulate for all combinations of value.
Yes, you can. Maybe you can use an
Oh,
output,
okay. Yeah.
or else you can define with limits of likelihood and manually define all the values. If it is 3-bit, maybe manually you can define all the combinations. Otherwise, you can use the output. So this #5 is used as a delay statement. So this is not synthesizable, but in test bench to obtain we are initializing with a set of value. After certain delay, we are initializing with another set of value. So we use this #5 statement, and here you can see the output from this $monitor statement. Yes, after 5 delay, we obtained 101 and we have applied 1x1, and the result is all zeros. After 10 time scale 10, we have applied 111 101 and the output is all zeros. this is with equality and inequality, case equality expressions. Any doubts with this expression? So like if you want to obtain an AND gate truth table for all the values 0, 1, x and z, when it is 0 it will be all 0, so this also we can fill 1 and 1 will be 1. Okay, so 1 and x will be what we will get if we AND 1 with z and 1 with x. Now I am audible, right? Okay, so we will get x and 1 and is z high impedance. You can turn on your mic and then reply.
Z, madam.
Z, but z is like an high impedance state, so if I have a value which is floating, I will have an high impedance state, but in Boolean logic it has to settle either to 0 or 1, so we don't know what is the value. But now we don't know the value, right? Like if I have a wire, say I have an AND gate which is driving and another OR gate, and I have one wire which is floating, so this node can take either 0 or 1, and based on say like 0 0, I have a 0 here. If it is 0 I will get a 0, otherwise 0. If I have 1, then I will get a 0 or 1, so in that way I will be getting maybe you can turn on your mic and say.
Then it's don't care, madam, X.
Yes, is it fine? Like why when we AND any logic value with z or any operation with a high impedance state, we obtain a don't care? Is this statement clear?
Yes, madam.
Then if we have an high impedance state and don't care as an input, then the output will be
Don't care.
well both the inputs are
Don't please.
Don't care.
we can try this video playground, this truth table. So now I will try the AND gate input truth table. So is this module definition correct? So here we have to consider the assignments and the declaration of the variable. So is this definition of module correct?
No, madam.
What are the changes that we have to make?
Assign statement.
Any other changes?
That is input A, comma input B. You should give it.
Okay. So here I am using an assigned statement. So this RHS variable should be of wire type or register type. And also
It should be a wire.
this is a continuous assignment or a procedural assignment?
Continuous assign.
Here I have defined output as a register type, so this reg also should not come. And also this you can define as input A comma B. This declaration will not give any syntax error. Like you can define input A, B, C, all the input port list. So here also in the port list after this module name you can define it. The variables all followed after this will be considered as an input. So you can have A comma B comma C also. This is actually syntactically correct statement. So here this register should not come because it is a continuous assignment, and assign is the keyword. Then I am using the manual way of giving all the combinations of the inputs, so I will directly take it from here itself. So I have defined the complete truth table A0001 and 0x0z, all the 16 combinations. So like this truth table. So you can see this is the results. So when we perform 1 and x, the output will be x, don't care, and also 1 and z, then also output will be don't care. If we perform z and z also, the output will be don't care. Is this clear? Any doubts still here? Any doubts? So this is clear. Shall we try like one non-blocking and blocking assignments?
Yeah, okay.
So we will, any module we will start with module keyword and end with end module keyword. Is this fine? Then we have to have a module name, so let us have it's a user defined name, blocking and blocking. So let me consider A, B and Y has a port list. So we'll define input as A, B and output as Y. Always. So whenever A or B changes, this statements inside the always block will be executed. So let me define any one temporary variable A equal to and then Y is equal to Y1. Is this module definition correct?
That's correct.
This y1 I have not defined it, so y1 should be of wire type or register type.
It's a register.
I have to define y1 as register, and this y I have given directly as out of y, output y. So by default, if I don't mention anything as out, just directly with keyword output, then it will be wire type variable. So can I use a wire type variable inside this block? Here I have
Yeah.
so here I have to define it again as register type. So in this changes will be I have defined y has a register type variable, and then I have to declare this y1 value, y1 variable. Now is this correct? Here in the test bench I have to define declare a and b. This a and b will be a wire type or register type.
It's a register.
Y will be
It's a wire.
Wire.
and in the initial begin is like it is non-synthesizable statements, and once the block will be executed. So here we can have y a equal to 1, b is equal to 0. Now is this test bench correct?
End of the statement semicolon.
Yes. Now is it correct? I have defined a module named test bench, and I have given register and wire. I have initialized the variable and I have printed the values. Am I missing anything here?
Yeah, module instantiation.
So I have to call this block, and then I have to pass the values, and here I can give the instantiation name. Is the syntax of always correct?
We have to use at the rate, madam.
Okay, so this is blocking or non-blocking statement. So the value of the y will be when A is 1 and B is 0. When I assign A has 1 and B has 0, this is a blocking statement, then what will be the value of output Y?
A equal to 1 and B equal to 1.
I have not assigned, I am not assigning to A or B, like I am assigning A has 1 and B has 0, and then I am assigning back to Y1 and Y. This is the code. This value I am defining in the test bench as A equal to 1, B is equal to 0. So here what will be the execution? A is 1 and B is 0. If this is the input I am applying through the test bench, then this will be the execution statements. Is it fine? Is this way of applying the input stimulus to the module clear?
Ma'am, explain this one, madam.
So I am having a block where I have A, B and Y has the output. Now to this block I am instantiating and I am applying this value. So I am having a register which as A, B, and this output I am driving it as output. So this I am defining with wire variable, and this too I am defining with register keyword. This one is our module. So I am instantiating this as a variable, okay, as a DUT. Okay, this is the test bench. So any module definition will start with module and end module. This one is used to display. So I am displaying the time and then A value, B value and the output values, and then the I want A here, B here and then Y here, and then I am initializing this values. So initial will execute once. Okay. So I am initializing that A has 1 and I am initializing the B has 0, and this block I have to instantiate. So I am instantiating as DUT here, and then I have to store this output in a variable. So I have defined the output to be wire type and register, and I have applied the input A, B and Y. This order is like input followed by output is same as in the module definition. Otherwise another way of doing instantiation is dot A, the name it has same as in this module, and the name variable name same as in this test bench, comma complete port list a b dot out. Okay, here it is y dot y. So if I wish to apply like more, like all the combinations, I will apply with some delay. So first I will apply 0 and 1, then 0 0, then say 1 1. So while passing the inputs in this initial begin block, I will like first define hash 5 a equal to 1, b is equal to 1. Then again with some delay I will apply 0, b is equal to 0. Again some delay, 1, b is equal to 0. So this is the time. We define any delay using this symbol hash. Is it clear? The test bench definition and the syntax, is this clear? Hello? So okay, after this I will like give the value a equal to 1 and then b equal to 1. So now for this combination, okay, I will use a delay and then value we wish to simulate is a equal to 1 and b equal to 1. So can you like guess the output? Try by manually assigning it. When you have a equal to 0, a equal to 1, b equal to 0 and a equal to 1 and b equal to 1, what will be the output? This is the statement. So expression first a equal to 1, b equal to 0 and 1 1. What will be the value of y? I start like executing. What will be the value of y1 when a equal to 1? So like when a equal to 1, y1 will be 1 and this y1 will be y1 and b is 1, so y will be 1. If b is 0, then the output will be 0. So we will get when a equal to 1, b equal to 1, y1 is 1 and y is 1. When a is 1, b is 0, y is 0. Okay. Then if I have here a non-blocking assignment, then what will be the output? You can repeat. Yes, please.
Both will be don't care.
Yes, correct. Because a value will be stored in some temporary register, and so here y1 will not be available. Why it is coming?
Ma'am,
Yes, yes, yes.
can you explain why the both values are don't care?
Yes. So I am assigning a has 1 and b has say 1. So if this assignment statement is used, this is blocking or non-blocking?
Non-blocking.
Okay. So this will not block the execution. So I will be storing this in some it will store it in some temporary value, the value of a, and in some other temporary variable the value of b and y1. We don't know what is y1, and the value of b is 1. So the final, after the completion of this block, the finally a value will be stored in the y1. So we will get y1 as 1 and y has 1 and don't care, so value will be don't care.
Okay, madam.
Whereas if we had this will be for non-blocking. If we are using a blocking assignment, then it will be executing this in the order given in the list. So first it will execute y1 is equal to a, so y1 will be getting the value 1, and then next it will execute y1 is equal to a b and y1, so it will get b is 1 and 1, so it will get the value 1. So okay, but when we have a equal to 1 and b is equal to 0, then what will be the value?
Same, both will be don't care only.
When a equal to 1 and b is equal to 0, when b is equal to 0, whatever the value of y1, the final output will be like 0 only.
A will be don't care and B will be 0.
Yes. But why the simulation is giving me y is equal to 1 when I am having a equal to 1 and b equal to 1? Some error in the code. Why I am getting like when a equal to 1 and b equal to 1, the output should be like don't care. Why I am getting like y equal to 0? First statement, is this correct? Like when a equal to 0 and b equal to 1, the output y is don't care. Is the output correct when time is 5? Yes. What will be the output when a equal to 0 and b equal to 1? Hello? Can anyone say like why I am getting y equal to 0 at time 10 when my inputs are a equal to 1 and b equal to 1? Because 1 and don't care will be a don't care only, right?
Ma'am, don't know, ma'am. Explain.
Because this block will be executed and I am giving a delay, so it is executing like continuously. So after this execution, the y1 will obtain the value. When it is time scale 10, the y will be having the previous value of a, which is nothing but 0. So 0 and 1 will give me the value y equal to 0.
But can't this simulation be run for t is equal to 0, ma'am?
Yes, it can be run. T is equal to 0, there won't be any change in the a and b, so this is not simulated. As I have given the input at x equal to
No,
0.
because previously when you executed, you were not able to get y is equal to don't care for the first condition. But later on, you have added the delay here. So once you've added the delay, we were able to get that y is equal to don't care, isn't it?
No, no, no. Previously, I was was executing a equal to 1 and b equal to 0.
Okay, fine.
A is equal to 1 and b equal to 0. So b is 0 and any input of candidate is 0. So we were getting output as 0.
Okay, fine, ma'am. Got it. Thank you.
Competency 2. Yes. Here also we are getting y equal to 1 now because the previous value 1 is taken. 1 and 1 is 1 and this 0 and 1 is 0. And now we have executed this. I have defined without any delay, so it is taken for t equal to 0. If you have any other doubts we can discuss, otherwise like we can try with logical and bitwise operators. Any doubts till here? Designing of combination circuits, defining a module and defining a test bench.
No, madam.
So like can we try defining a logical and an bitwise AND operator difference? So I am defining a 3-bit A, B and an output also a 3-bit. So how will I assign this output variable to A and B? Is this assignment correct or I have to use any other keyword? Because
Assign.
so this single ampersand represent logical or bitwise AND operation.
Bitwise operate.
So here also I have defined a 3-bit A, B and then output I have defined as out. Then define under test and B. So 3-bit variable what will be the output if I have like when I apply the input 001 and 101?
001.
Yes. Can we try why I'm getting some error? Syntax error because I have defined y output as only one variable, but
Yes, actually, B is equal to.
B is equal to
There you didn't define the size, and then it's a binary or it's a decimal or.
so I'm getting the value 1 because I'm printing it in decimal values. writing it in binary itself. I'm getting 001. What will be the output if I have double ampersand here? So instead of a bitwise AND, I am using a logical AND operator. And maybe I can change this to same value. Now my A is 5 and B is 5. What will be the output if I use a logical AND, and what will be the output if I use a bitwise AND? Is it fine? Like I am defining an output to be A double ampersand B, which is like logical AND. What will be the output?
I think it's one, right?
Sorry,
One will be the
1 will be the output. If I have only 1 ampersand,
101.
any other doubts in that? X equal to 101, P equal to 101, Y is 101.
Ma'am, how bitwise and logical getting, madam? I don't know.
Yes, so if I am using 1 ampersand, this is called as can you see, like double ampersand, it is for logical and 1 ampersand is for bitwise AND. So if I have 101 and I use 1 ampersand, so bit by bit I will be performing the AND operation. So I will be performing bit by bit AND operation. So 1 and 1, 1, 0, 1. So the output will be 101. Whereas if I am using a logical operator, this is a true value, this is a true value. 0 is considered as a false, but any other value like this 101, which is a decimal 5, will be considered as true. So this and this are true, so the output will be 1.
Okay, madam. Fine.
Ma'am, what about the negative numbers?
Yes, negative numbers we will be representing as 2's complement form or anything. So the MSB bit only will be having 1. If we say 2's complement form, the MSB bit sign we will consider one sign bit, which is 1, and the other bits will be considering the magnitude. So again it will be performing like considering this complete thing as a true and the other value as a true. This is true, and another, if you have like starting with 1 also, any number other than 0 it will be considering like true, because for positive or negative only this MSB bit will be different.
Complementary
Yes.
is for a decimal number or hexadecimal. It is and for decimal numbers, how it will take.
Again it is performing the operation after converting it to the binary equivalent.
Okay, yeah, got it.
In test bench, when we are applying only, we will be using a decimal or any other, but the
Okay, got it, ma'am. Yeah, thank you.
So here I am having 101 and 001. Both, if I perform a logical AND, it is again giving me 1 because both are true. If I am having a 0 here, then I will be getting an output to be 0. And if say the decimal equivalent 1 bit decimal value, this is 5, and I consider a 1 bit decimal value to be again say 5, and the equivalent final operation will be performed using the equivalent binary value, so the output will be again 101. Sorry, it is logical, so 1. Any other doubts?
Ma'am, for the same bitwise operation, can we use A is a decimal and B is binary or octal? Anything?
Yes, yes. So if I say like A is decimal 5 and B I can say to be an octal. 5 is valid, so I can directly run this. The values like 3 tick D5 is for like our understanding. Finally it will know that okay, it is decimal value, it will convert to the equivalent binary and perform the operation. It will see octal and so convert it to the equivalent decimal and the binary and then perform this operation. So you can see the same results we are getting.
Okay, madam.
Any other doubts?
Can you try it for different numbers, huh? Different A and B consist of different numbers.
So A is 3, which is 0 1 1, and B I have given 6 like 1 1 0. So we are getting the final output as 0 1 0. I am printing it here with percentage %b, so you are like we are able to see in binary format. Again you can print it with decimal or octal or any number system here in the dollar monitor statement.
Okay, ma'am.
You can try executing the course in this EDA program, and here you can choose the tool to be like in like the first one I have chosen, and then you can give this open EP wave to like display the waveforms, and you can directly run here. And this one test bench and design, I am using Verilog, so I have chosen the Verilog.
Ma'am, actually, I same procedure I followed, but I am not seeing any waveform. Can you please help me for that?
Here you have to click that open EP wave after run.
After run or before run? Yes, yes, yes. I enabled it and then I clicked on the run
Yes.
and then but I didn't see anything.
Maybe can you share your screen? I will
I yeah, sure.
stop sharing.
Yes, I shared my screen. Are you able to see?
Yes, yes.
Yeah. So this is the actually this is the code. And then this is the test bench, and I wrote the statements initial and here dump file. I click the this run, and then I okay, everything is okay. I think so. So no, but I didn't see any waveform.
Maybe can you compress or reach maximum child count? Maybe can you go little down? Or okay, it is still running. Yes, yes, yes. Maybe can you share me once screen?
Yeah. This.
In the last line, as previously we said 1:1, we have given one more delay, right? As 10. Can you enter that delay alone?
Yeah.
Okay, fine, fine, fine.
See, actually, I didn't see any waveform.
The waveform should be okay. There's another window. You have stored it with dot abcd, right? That file, dump file.
Yes, yes. Here, yes, dump file. Yes.
Okay. Before the always found like end is there, no? You give $10 and once it is 10, as 10 dollar stop.
Here, right?
No, no. Before the end.
Okay. Hash 10.
No, uh, that last statement is there, right? Input to state one, stay alive. As 10. I'm running it.
Yes. So we need to add signals right here.
Yes, you can add, but it should come before.
It's okay. Yeah.
Since we have not stopped that simulation, it was showing us an error that it has reached the execution state. So due to the
Mm.
delay, you should stop the simulation.
Yes, 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 yes. Mm. Thank you, ma'am. Thank you for.
Any other doubts?
Ma'am, actually, you explained about some material PDF. How can we get that, madam?
Uh, you are shared with any drive link or YouTube link. I think you will be receiving one YouTube link and then one drive link where we will be sharing this file and the recordings of today's lecture.
Okay, ma'am.
Did you receive for your last video? Like maybe you will be receiving one drive link with all the materials, the PDF which we are using and the writings which we are writing. Any other doubts? So if you have any other doubts, you can.
Oh,
Okay. Shall we
yeah.
proceed to the
Thank you.
class? Yes. Thank you.
Thank you.